Welcome to this Chemistry Educational Explainer. We're going to take a crucial piece of A-level chemistry and turn it into your very own molecular detectives toolkit. You know, if you've ever looked at a chemical test and wondered how it actually manages to spot a specific group of atoms hidden inside a complex molecule, well, you are in the perfect place. Today, we're completely demystifying the iodoform test. Picture this. You're standing in the lab, staring at an unknown, perfectly clear liquid. It could be one of a dozen different compounds. You need to definitively prove its identity, and you need to do it quickly. How do you actually identify a hidden methyl ketone structure just lurking right there in the test tube? Well, let's put on our detective hats and see exactly how we can catch these specific molecular structures absolutely red-handed using some brilliantly simple chemistry. So here's our game plan for today. We'll start by meeting the iodoform test, then go over the reagents and procedure, decode the results, dig into the underlying chemistry, and finish up with your ultimate exam cheat sheet. Let's dive right in. All right, section 1. Meet the iodoform test. Let's pin down exactly what our primary interrogation technique actually is. The absolute most important thing to grasp here is that the iodoform test is incredibly specific. It's not just looking for any random ketone or alcohol. No, it's hunting specifically for the CH₃CO group, what we call a methyl ketone, and the CH₃CHOH group. And for those secondary alcohols, that OH group literally has to be on the second carbon of the chain to trigger a reaction. It's basically a highly tuned fingerprint scanner. If your molecule doesn't have these exact structures, or can't be quickly oxidized into one that does, well, the scanner just won't trigger. Moving right along to section 2, reagents and procedure. Let's take this from theory straight into the practical lab setting. To actually pull off this test, you only need 2 super common reagents. First up, iodine solution. Second, sodium hydroxide solution. And when you mix these 2 bad boys together in the lab, chemists call the resulting mixture alkaline iodine. Definitely keep that term in your back pocket for exams. This combo is the reactive heart of the whole test. It provides both the iodine atoms and the alkaline environment you need to literally tear those target molecules apart. Now, the procedure itself is just brilliantly simple. You literally just mix your sample with iodine, add in your sodium hydroxide, maybe apply a little gentle warmth if it needs a tiny push, and then you just watch what happens. It really is that easy. Okay, section 3, decoding the results. Let's see how that physical procedure actually turns into actionable data. What I absolutely love about this test is the sensory anchoring. A positive result isn't some tiny blink and you miss it color shift. Nope. It gives you a highly visual, totally undeniable, pale yellow crystalline precipitate. Plus, it has this incredibly distinct antiseptic smell. Think of like the scent of an old school hospital corridor. That contrasts completely with the negative test, where absolutely no yellow precipitate forms whatsoever. The liquid just stays completely clear or keeps the color of the unreacted iodine. So if you get that yellow precipitate and that distinct hospital smell, boom, you immediately know you've caught your culprit. It narrows it down to a very exclusive club. We're talking ethanol, which, by the way, is the only aldehyde that works. We're talking methyl ketones like propanone and butane-2,1. And we're talking specific alcohols like ethanol and propanol. Just remember, those alcohols only work because our alkaline iodine actually oxidizes them first, turning them into the required methyl ketone structure before the main event even happens. On the flip side, compounds like methanol, propanol, butanol, methanol, and propan-1-ol, they're going to give you a stubbornly negative result. And why is that? It's simply because they completely lack that vital CH₃CO structure, and there's no way to oxidize them into it. No methyl ketone group literally means no yellow precipitate. It is a hard and fast rule. All right, section 4, the underlying chemistry. We know what happens in the test tube, but let's satisfy that inner chemist. Why does this actually work on a molecular level? The core mechanic here is basically a 2-step dance. First, the CH3 group attached to the carbonyl carbon goes through what we call iodination. That just means the hydrogen atoms are systematically swapped out for iodine atoms. Once it's completely loaded up with iodine, the molecule gets extremely unstable in those alkaline conditions, and it actually cleaves. It just snaps right apart. And breaking that carbon-carbon bond is exactly what produces our pale yellow precipitate, the iodoform molecule itself, CHI₃. This equation brilliantly shows the exact transformation using ethanol as our starting line. Now, pay close attention to the balancing here because it is a classic exam trap.
One single molecule of ethanol requires exactly 3 molecules of iodine and 4 of sodium hydroxide. And through that iodination and snapping process we just talked about, it spits out 1 molecule of our yellow CHI₃ precipitate, plus sodium formate, 3 molecules of sodium iodide, and 3 molecules of water.
It's super similar if we look at the equation for propanone. The structure is almost identical. You still need those exact same 3 iodines and 4 sodium hydroxides. The really big difference? The byproduct. Because propanone has an extra methyl group compared to ethanol, you end up with sodium acetate, CH3CONA, instead of sodium formate. But the main event is exactly the same: successful cleavage and the formation of that beautiful yellow iodoform precipitate.
And finally, Section 5, your exam cheat sheet. Let's pull everything together into a rapid-fire summary.
I highly recommend taking a second right here. Go ahead, pause the explainer and screenshot this matrix. Knowing exactly which compound types trigger a positive or negative result is going to save you so much critical time on test day. Just notice how ethanol is literally the only positive aldehyde, and ethanol is the only positive primary alcohol. Everything else just falls neatly into either the methyl ketone bucket or that specific secondary alcohol bucket.
So as a molecular detective, your ultimate shortcut is just hunting for those 2 very specific fingerprints. When a question asks about the iodoform test, immediately scan the structure. You are looking for CH3CO- or CH3CHOH-. If either of those are sitting right there, or if they can be formed by oxidation, you are absolutely guaranteed to get that pale yellow precipitate. That is your golden rule.
All right, as we wrap up this explainer, I'm going to leave you with a rapid-fire deduction to really test your new knowledge. If you're told an unknown liquid is a primary alcohol and it gives a positive iodoform test, what is literally the only compound it could possibly be? Think back to our cheat sheet, let that question simmer, and keep that chemical curiosity firing until next time.